So this is chapter 6.3, problem number 27. We're going to use the washer method to find the area of a solid, or to find the volume of a solid of revolution. And we're revolving about the x-axis, and we're going to use the washer method. So we're given two functions. One's a cubic and one's a line, and we're looking at this region shaded in yellow. We're going to revolve around the x-axis, and in doing so, we're going to create a solid of revolution that we want to find the volume for. So the first thing to do is to identify the limits of integration. Okay, so identify the limits of integration. Nothing was given to us, so we need to algebraically solve for them. So equate the two functions. We did the setup of this in class, but I just want to, for completeness, show everything, since it's the first real example that we have of the washer method. So I factored out a negative x, and I'm left with x squared minus 4x plus 4, which will again factor x minus 2, which provides us with the limits of integration of 0 and 2. So notice, let me grab yellow, the function on top, f of x, is the line, and g of x is the cubic function. So let's build the integral. Let me pause here for a minute. Okay, sorry about that. So building this integral, we integrate from 0 to 2, and here's our washer method. Right, we're looking at pi times, right, this is your radius of the outer, right, minus the radius of the inner. And simplifying that algebraically, I'm going to pull out pi so I can get rid of that. And then let's algebraically work on this. We're left with 16x squared minus, and I'm going to expand this to get x to the 6th minus x to the 5th plus 16x to the 4th dx. Scroll here. Okay. Pick another color so we can pick up. So let's take care of the sign and then use the power rule on this. I'm going to combine the like terms, and I'm going to write it in decreasing order of power. Okay. Taking the antiderivative, you get minus x to the 7th over 7 plus 4x to the 6th over 3 minus 16x to the 5th over 5 plus 16x cubed over 3. And evaluate that between 0 and 2. Let's substitute in, and there's a high probability of a mathematical error when you're working with these things. So just, do your best to be careful here. And again, I mean, I've made it as well, so it's very easy to do. Very easy to do. I did check this answer, so even though as nasty as the fractional math is, it is